Hello and welcome to my channel. I am Ensa Modestin. Please, if you are new here, kindly subscribe to my channel. And if you have been watching my videos and if you're not yet subscribed, please kindly subscribe for us to grow the mathematics community. In this lesson, we're looking at a point of inflection and concativity of a function. So for the point of inflection, you'll be using the concativity test. So join me as we go through this lesson. Thanks to Henry from University of Legon, Ghana for requesting for this video. Now, this is the question that I will use. If we have f of x, we have f of x equal to x times 4 minus x all to the power 2 out of 3. What is the point of inflection? And on which interval is this function concave up or concave down? Join me as we go through it step by step. Now, what you have to do is that you have to find the first derivative. So here, I'm going to use the product rule. The derivative of x with respect to x is 1 times the whole of this will give us 4 minus x. Okay, let's do it step by step. We have 4 minus x to the power 2 on 3 times the derivative of x with respect to x plus x times the derivative of 4 minus x to the power 2 on 3 with respect to x. So here, if we differentiate x with respect to x, we get 1 times 0, this will get 4 minus x to the power 2 on 3 plus x. Here, we are going to use the chain rule. So we take the power and bring it in front. Times we differentiate what is here, we have negative 1 times 4 minus x to the power 1 out of 3. That is, if you subtract 1 from this, yeah, you get negative 1 out of 3 rather. Very, very simple as that. So let's move on. This will give us 4 minus x to the power 2 out of 3 minus 2x all divided by 3 times 4 minus x to the power positive 1 out of 3. So we check this one. Since we have power negative, it will come to the denominator to become power positive, and this is at the denominator, and positive times negative will give us negative. 2 times x will give us 2x. Now, this is the LCM, so we multiply this by that. So we are going to get 3 times 4 minus x. And since this and that are the same, we add the powers 2 on 3 plus 1 on 3 minus 2x all divided by 3 times 4 minus x to the power 1 out of 3. So check how I did it. This one is over 1. So you find the LCM of this and that is this. 1 divided this is the same as this. So you multiply this by that. This divided by that, you get 1. You multiply it by this, you get this 1. So this will give us 3 into bracket 4 minus x minus 2x all divided by 3 times 4 minus x to the power 1 out of 3. 2 on 3 plus 1 on 3 will give us power 1. So this will give us 12 minus 3x minus 2x all divided by 3 times 4 minus x to the power 1 out of 3. And this will give us 12 minus 5x all divided by 3 times 4 minus x to the power 1 out of 3 as f prime of x. So we've done the first derivative. So let's put the first derivative down here. We have f prime of x to be equal to 12 minus 5x all divided by let's put it under here. We have f prime of x to be equal to 12 minus 5x all divided by 3 times 4 minus x to the power 1 out of 3. Now let's find the second derivative. Now, what is f prime of x? So here we use the quotient rule. So we differentiate the numerator and multiply it by the denominator. So if you differentiate the numerator, you have minus 5 times 3 times 4 minus x to the power 1 out of 3 minus, then you differentiate the denominator. So here we have 3 here already. And we're going to differentiate this one. So we bring the power down times 4 minus x, then subtract 1 from the power to get negative 2 out of 3 times, we differentiate what is inside to get negative 1. So check the description and watch my video on derivative using the chain rule. You understand how to differentiate this. We have 3 here already. So to differentiate this, just bring the power down and then subtract 1 from the power. Then after that, we differentiate what is inside and multiply it. So since we are using the quotient rule, we divide all by 3 times 4 minus x to the power 1 out of 3 squared. Now, let's move with it. So here, what can we do? We are going to have 4 minus x to the power 1 out of 3. We have 4 minus x to the power negative 2 out of 3. So this is the smallest power, so we can factorize it out. So we have 4 minus x to the power negative 2 out of 3 times minus 15 times 4 minus x plus, here 3 will cancel 3. And what will remain here? That is what we brought here. So we take 1 here. All divided by 9 times 4 minus x to the power 2 out of 3. Wow, that is very, very nice. So we check this one. If we multiply this by that, negative 2 out of 3 plus the 1 here will give you 1 out of 3. That is what I did. And if you multiply this by that, you are going to get what we have. And here 3 will cancel 3. So now let's move on. So this will give us minus 15 times 4. So here minus 15 times 4 will give us, oh wow, there's a mistake here. I didn't multiply this, times 12 minus 5x. Wow. So here we are going to have negative times negative, positive 1, 12 minus 5x. Wow. I didn't do that one. Very, very important. I didn't do that one. So that is what we are going to have. Oh, it's good now. When I finished differentiating this, I did not multiply it by the numerator. So this is the numerator that we have. So I hope now we can move with that. Very simple. So we are now going to have, since this has negative power, we will bring it down to the denominator. So you are going to have minus 60 plus 15x plus 12 minus 5x all divided by this as negative power. So if it comes down, it will become positive. So you have 9 times 4 minus x to the power 2 out of 3 times 4 minus x to the power 2 out of 3. Very simple as that. So you see how I'm doing the simplification. This has negative power, so just bring it down to the denominator. Very, very simple. Here, we don't have any denominator here. If there exists a denominator here, you bring it down to multiply this, and then you bring all of them down. If the results also contains another negative power, but we don't have any denominator here, so we just bring it down to this side. That is all. Now, this will give us minus 48 plus 10x all divided by 9 times 4 minus x to the power 4 out of 3. Because 2/3 plus 2/3 will give us 4/3 as our second derivative. So let me write the second derivative also down. I think we are very, very good to go. That is f prime prime of x equals minus 48 plus 10x all divided by 9 times 4 minus x to the power 4 out of 3. Wow. Now, let us see the next step. Our next step is to find the critical points by using the second derivative. So here, you first take f of f prime prime to equal to 0. This means that minus 48 plus 10x divided by 9 times 4 minus x to the power 4 out of 3 is equal to 0. And the numerator will become minus 48 plus 10x equal to 0. And we have x equal to 4.8. Wow. Then, this is also a rational function. So we can find the value of x for which the function is undefined. So it means that you take 9 times 4 minus x to the power 4 out of 3 to equal to 0. That will equate the denominator to 0. And this will give us x equal to 4. Because if you divide both sides by 9, you get 0. And if you take power, okay, let's do it step by step. You divide it by 9, you divide it by 9, so you get 4 minus x to the power 4 on 3 equal to 0. Wow. Now, this implies that 4 minus x is equal to 0 to the power 3 out of 4. This is 4 on 3 times 3 out of 4. 4 cancel 4, 3 cancel 3. So you still have 4 minus x equal to 0, which implies x equal to 4. So once you have this being equal to 0, it will only remain with this one that we can equate to 0. Very, very simple as that. So we have 9 times 4 minus x, 4 on 3 equal to 0. Just take the inner one, x equal to 4. Now, let us look at the interval that we've got in here. So here, the interval that we've got in here will help us, because here we have 4 and 4.8. So we can say that the interval is negative infinity to 4. Then from 4 to 4.8, and then from 4.8 to positive infinity. So let's draw a table for that one. Let's do our interval here. That is minus infinity is less than x less than 4. Then we have 4 less than x less than 4.8. Then we have 4.8 less than x less than positive infinity. Then you take a test value. Then you look at f prime prime of x, and then you check the concativity here. Okay, so let's see. If we look at this interval, we can have 0 there. So let me make this one very small. Test value. So there's 0 within this interval, so I'll use 0 to test. If you look at this interval, I have 4.1, 4.2, 4.3, 4.4, so I'll use 4.1 to check. And 4.8 up to infinity, I'll just use 5 to check. So now we are going to find f prime prime of 0. Then here you find f prime prime of 4.1, and you find f prime prime of 5. So let's see. Take your calculator. If we take 0, you put it here, you put it here. I've done it already here. So use your calculator to cross check. If you put in 0 here, we are going to get f prime prime of 0 to be negative 0.84 to two significant figures. So this figure is less than 0. This one is less than 0. So this one is less than 0. Oh, sorry. We have minus 0.84, which is less than 0. Wow, okay. Now, if we put in 4.1 into the second derivative, we are going to get minus 16.76 to 4 significant figures, or to 2 decimal places. And this one too is less than 0. Now, if we put in 5 for x, we are going to get 0.22, which is greater than 0. Now, so here for less than 0, we say that it is concave down. Less than 0, so it is concave down. Greater than 0, so it is concave up. Very, very simple like that. Now, how do you find the points of inflection? Now, we say that the point of inflection is where the second derivative changes sign. So let's see here. The second derivative is less than 0. If we come to this place, the second derivative is still less than 0. So it has not changed sign. So it means that if we come to 4, and from 4 going, that is from 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, up to, let's say, 4.7999. This one is still less than 0. So it means that this 4 is not a point of inflection. But when you reach 4.8 and we are passing by 4.8, let's say that if we go to 4.81, wow, you see that the second derivative changes sign. So if you reach 4.8, the second derivative changes sign. What do I mean by the second derivative changing sign? Here, the second derivative is now greater than 0. You can put in 4.81 or 4.80001 and see. You see that the answer that you get will be greater than 0. So we say that 4.8 is the point of inflection. So 4.8 is a point of inflection. 4.8 is a point of inflection because on reaching 4.8, the second derivative changes sign. But here when we reach 4 here, the second derivative did not change sign. It did not change sign. And within this period too, the second derivative did not change sign. But here when we reach 4.8 here, and we are moving to 4.01, sorry, 4.801, 4.9, and the second derivative changes sign. So 4.8 is the only point of inflection. Now, let us put 4.8 into our f of x, so that you get the point of inflection there. So now, if you put it into f of x, we are going to get, I've done it already here. If you put it into f of x here, we are going to get 4.8, 0.74 as our point of inflection. Now, there's one thing that we should note here. This place, when we are doing the substitution, look at this one. If you are using calculator and you point, you see that here, if we put in 5, you are going to get -1 to the power 4 out of 3. If you use calculator to punch this one straight, you will get your answer in complex numbers. So what you have to do is that when you reach here, just take your time. It is 9 times, just take, either you take cube root of -1, and then after that, you square that, you raise the answer to the power 4. Or you take 9 times -1 to the power 4, and after that, you take the answer to the power 1 out of 3. So that is the trick there. If you substitute something that will give you negative, that is the trick there. Thank you for watching. Henry, I hope now you've gotten it. Bye bye.